Click here, go live. Yeah, go live is available. Okay, so you can see on the YouTube also if you feel there is some network issue in Zoom app. So it's available there on the YouTube also. We are live. We're live there. Okay. Okay, students. So first of all, we'll start the revision of interference with this. Please watch this video carefully. I'll launch it at least 2 to 3 times, 2 times at least. Okay, so we can focus carefully what is happening. Watch this video carefully again. This is a revision part. Okay, so I hope you have seen the video. Okay, so now we'll see some next part of this, like for the revision. We have seen the definition of interference. What was that? You know, it's nothing like just. I mean, it's just a two superposition of the two waves, overlapping of two waves, है ना? So these are some conditions. Okay, before this, before I show you these two conditions, anybody can answer me that what is the strict condition? Two strict conditions so that the interference pattern is to be like we can observe the interference pattern continuously 24/7. What's the strict two conditions? I've given you the hint. These are two conditions. Answer me in the chat box. Okay. So then we'll see the next slide. Answer anyone. Students reply in the chat box. Okay. So what are the strict two conditions for to observe the interference? Same frequency and wavelengths. नहीं वो नमस्कार वाला सिस्टम ठीक है अपना बढ़िया ही लगता है. Okay, see, students, these are the two conditions. Yeah, very good. So the waves should be monochromatic. इसका मतलब क्या होता है? Wave should be monochromatic मतलब it must be having single. Mono मतलब single. Chromatic मतलब having only one wavelength. Okay, so they should be having a single wavelength. And sources should be coherent. Coherent matlab having the fixed frequency and phase difference there. Remember these things. Very good. Next, say I'll be fast. Don't worry. Coherent. We have seen this thing. This is the coherent light. Coherent sources are those sources of light which emit coherent sources are those sources of light which emit waves having same frequencies and zero or constant phase difference. Okay, these are the coherent light. Incoherent sources means that emit waves having the random frequencies and phase difference. And through the picture you can see, this gives a picture of incoherent. So in this picture, if you see, students, what we are doing, we are comparing the, no, we are not comparing, we are converting what? The polychromatic, this is polychromatic coherent light into what? Look, hold on, this is a polychromatic incoherent light into what? The monochromatic coherent light. Okay, we are converting here polychromatic incoherent light into monochromatic coherent light. Okay. So this was the question, that suppose four independent waves are represented by the equation like this. Y1 equals to A1 sin omega t, Y2 equals to this, Y3 equals to this, Y4 equals to this. So there was a question. Okay, reply in the chat box. These all questions was completed in your class. Reply in the chat box. Were all these questions completed in your class or not? Reply in the chat box. Were all these questions completed? See, I have seen on the YouTube, you people are saying lie. Okay, we haven't completed anything. Yeah, no, answer is not A1 method, is B1 by 4. You people told like this, we completed interference. It's wrong, students. We haven't completed anything here. No interference completed. Okay, you people just simply told interference is completed. We just started with the definitions. So now we have to start from coherent source. Remember, These are the sources of light which emit waves of same frequency and zero or constant phase difference. This is the same frequency and zero or constant phase difference. And if you draw the chart here, means see, in this question, it was asked from you people that you have to find the pair of waves, say A13, B14, or C23 or D34, for which the phase difference comes out to be constant. And if the phase difference is constant, it means this will show this two pair of waves. It can be XY. I'm writing here XY, Y, because X can be either first number, X can be two number, X can be three number, or it can be four. Y can be one number, Y can be two number, Y can be three number, Y can be four number. Okay. So this is 1, 2, 3, 4. Like this, the pairs are there. 1, 2, 1, 3, 1, 4, 2, 3, 3, 4. So here in front of you, it is, if it comes constant, it means it's not a function of time. If it's not a function of time, we'll say this is what then? This will show the interference. Remember, for a pair of equations, say like this y1, y2, y3, y4, if you need to find from the pair of equations the phase difference will come out to be phi1 minus phi2. Okay. What is phi1, phi2 here? Suppose if the wave, if I take the wave 1, phi1 will be this. If I take the wave 2, phi2 will be this. Okay, like this, these angles. So first we'll make the chart of the pair of the waves as per given in the question. And then we'll see the phase differences. If the phase difference comes out to be not a function of time, that is independent, then we'll comment like this, that this is what? This will be coherent. Okay, it will show interference. So if you see here, if you see 1 and 3 wave, focus it carefully. If we see here 1 and 3 wave, okay, this is omega 1t. Okay, so if we see the pair of equations, for the pair of equations for which the phase difference is, say, not a function of time, it is what we'll say like time independent. Okay, so for that, the phase difference comes out to be del, it means constant. If the phase difference is constant, then we'll comment like this, that this will be coherent. These pair of waves will be coherent. That is 1, 3. You can see here, it's not constant, it's time dependent. If we see the C part, it's time dependent. If we see the D part, it's time dependent. So all this A, C, D are time independent. So we'll say like this will not show 24/7 what? Interference pattern. Continuously, they will not show interference pattern. They're not coherent. These pair of waves are, vibrations are not coherent. But we will see this B14 part. This is del. It's what? Time independent. It's constant. So this will show what? Interference. Okay. Now let us see somewhat the theory of the interference of waves. I hope you understood that point. Okay. So everyone have joined. See, you people told me like this, sir, we have complete interference. 5 people were lying. That's not right. This is wrong. Okay. We haven't completed interference. Okay. So all have joined, Ankita, and you people have joined completely. That's good. So students, be in the session now. It's very important. Now we are starting this theory of the interference of waves. If you are coming and going in between, it will create an issue for you. I mean, you'll not be able to understand completely. If you come after 15 minutes back in the session, so what the thing will gain? Because everything is connected in this physics also, in this chapter it's show. So let us go on now. So theory of interference of wave. Y1 is what? Suppose it's a wave. It's actually not a wave equation. We know this thing. The wave equation looks like kx minus omega t. Let us take it as like, suppose some wave is there, uska kuch vibration. Some wave is there, it's some point is there, uska kuch something vibration. Okay. So this y1 is what? The vibration, first vibration. This y2 is what? This y2 is what's the second vibration. This y1 is the first vibration of this wave, say y1. I'll mark it here. And this y2 is the second vibration, which is given like this. Y2, okay. So when we'll add this, the net wave which you will get on the right hand side is shown by this green color. This is green color, okay. And this is given by y equals to y1 plus y2. Okay. So this is the general equation of interference of two waves. Suppose we're having one wave vibration like this and second wave vibration like this. We have to assume it to be like of same wave. Take this equation as a wave equation. Don't take it as like vibration. Okay. So when these two waves will interfere, we'll get equation like this: y equals to y1 plus y2. Now we'll see somewhat more. We'll go deep in this theory of interference. Okay, and understand it more through the concepts. So this we know it is what? Y1 equals to a cos omega t, first vibration, first wave, then the second wave is this. Okay. So as per the general equation, if we add them, like it is known as what? The superposition principle. So what is happening if we add both the equations? This will become y equals to, say this carefully, this will become y equals to y1 plus y2. Okay. So let us mark the equations: a cos omega t plus phi. Hold on. See here, if I take a common from this, if I take this from this a common, and if I take out this a from this, if I take out this a from it, okay, so I'll get the value equals to cos omega t plus phi. So you know this thing, the formula of cos c plus d is what? 2 cos c minus d cos c plus d. Okay. So treat here c to be like cos omega t, sorry, c to be like omega t and d to be like omega t plus phi. You have to mark this, okay? Remember it. Take c equals to omega t and d equals to what? Omega t plus phi. And use this CD formula. Cos c plus cos d is what? 2 cos c minus d by 2 cos c plus d by 2. Okay. And then you will get this big formula here. So this is the general equation of interference of two waves, which are having initial equations as like this: a cos omega t, and second is a cos omega t plus phi. Okay. This is the general equation. Please note it down. If anybody is facing doubt, please reply in the chat box. Anyone is facing doubt, please reply in the chat box. See, one important point, one important fact which is connected with this equation is this. If you see the amplitude, it's a very big amplitude which is given by 2a cos phi by 2. It's a function of phase difference. So with the phase, amplitude will also change of this new wave equation, which is formed due to the superposition or overlapping of the two waves given by y1 and y2. Okay. So this is amplitude. If I erase this, you will get it proper. So see this. I think I can erase now complete fact. Okay, so it's visible to you. This is y equals to capital A cos omega t plus phi by 2. A is this, which is the amplitude of this interfered wave. It is a function of phase difference. Note all these things in your notebook, okay? And if you're feeling any doubt, then you can please reply in the chat box. Please note it down and reply in the chat box. Then we'll move for the next slide. Okay. Okay, I hope you have noted it down. Now we'll see the next slide. So now we'll see, okay, what's the doubt is? No doubt, okay, no doubt, fine. So see, now we'll see the condition of for constructive interference of waves. So we see the condition of constructive interference. See, first we'll see the intensity formula. Intensity should be maximum. So it's written here, intensity is proportional to amplitude ka square. Let us derive this equation first. We have seen in the previous equation of amplitude of the interfered wave. This is what? A equals to 2a cos phi by 2. This is equals to A equals to 2a cos phi by 2. So you see here carefully, amplitude comes out to be what? 2a cos phi by 2. Okay. Amplitude is what? 2a cos phi by 2. From that equation we have seen, interfered wave equation. Now we'll check, as we have seen in the video, that for the interference, there are bright bands and the dark bands. There are the bright bands and the dark bands. There are the bright bands and the dark bands. There are the bright bands and the dark bands. Okay. And the equation which governs this is this. I mean, that's equation amplitude which governs all this thing is this. Okay. So we know intensity is proportional to the amplitude ka square. This we all know, that intensity is proportional to the amplitude ka square. So make it square here like this. That is I equals to 4. If you square this term, this will give you 4a square cos square phi by 2. Intensity will be 4a square cos square phi by 2. Okay. So this will give you the result I equals to I naught cos square phi by 2. I naught will be what here? See, intensity will be I naught cos square phi by 2. Intensity will be maximum for what? Cos square phi by 2 to be 1. Okay. So for that to be 1, phase differences of constructive interference, this is equals to 0 plus minus 2 pi 2 n pi. Remember this. And actually what we are finding here? We are finding here the condition for constructive interference. That is phi, if you want to make this expression on the left hand side to be maximum, remember, if you want to make this expression on the left hand side to be maximum, you have to put this value to be maximum. For this to be maximum, it will be plus 1 here. Okay. So intensity will give you I naught here. And for this phase angle will come out to be 0 plus minus 2n plus minus 2 n pi. Fine. Okay. These are the angles here. Corresponding part difference, if you'll see, it's k delta x. Delta x equals to k is what? 2 pi by lambda. Del phi is this. So put here del phi equals to 2 n pi. 2 n pi. See, we got the angles for which this will be maximum, and for this intensity will be maximum. Now we need the part difference. Remember, part difference ka formula is k delta x equals to del phi. K is 2 pi by lambda. Delta x equals to what? This. Del phi will be equals to what? 2 n pi. Okay. So 2 pi and 2 pi will cancel. Part difference will get as n lambda like this. Okay. This is the part difference here. Okay. So corresponding part difference is in front of you. Fine. So if you use this part difference, this will be the condition of constructive interference. So see here again, the physical significance of whatever I told. I told like this, the angle difference between two vibrations, if it's or waves are like this, it's equals to phase difference. If it's like this 0 or general format is 2 n pi, then it will be bright spot. And the part difference, if you see equals to n lambda, then it will be bright spot. So these two waves are interfering like this, students. Oh, no. So you'll get the net equation like this, and this is equals to 2a. That is the maximum amplitude. Phase difference is equals to 0. Path difference is equals to 0. If you put here 0, this will give you 0 value. Okay. Angle mein, theek? If you put 2n pi, then also it will be maximum. Now let us see the destructive case. For destructive interference, intensity should be 0, because when the intensity goes 0, that will be dark band. When the intensity will be 0, that will be dark band. Okay. We know this is the intensity formula. It is equals to I naught cos square phi by 2. Cos square phi by 2 will be 0. Then intensity will go to what? 0 here. Okay. If cos square phi by 2 is 0, intensity will be 0. Fine. Simple. I will go to 0. See, this is phase difference angle. Phi equals to 0 plus minus pi plus minus 3 pi 2 and 1 plus pi. What is this? If we want to make this expression 0, we have to put this cos. I naught will not be 0 because it is the maximum value, kind of maximum intensity. Okay, I naught. We have to make this 0 because something multiplied by 0 will give you 0 result. Okay. So for this to make to 0, we have to make cos phi by 2 0. When it becomes 0 when? Cos is 0 when, students? It's 0 at pi by 2, pi by 4, and these values. Sorry, pi by 2, 3 pi by 2. At 90 degrees, the cos is 0. So finally, we'll get phi by 2 something compared with this, and 2 and 2 will cancel. So at last, we'll get this general value. That when the phase difference between the two waves, remember, when the phase difference between the two waves is equals to 2 and 1 plus pi here, okay? Phase difference is equals to 2 and 1 plus pi. Then if we use this phase difference, this will be the condition of destructive interference. Okay. And if we talk about the path difference, so what's the path difference? K delta x del phi. K is equals to 2 pi by lambda. I hope these things you have seen in waves. Ye wave number kya hota hai? This. Okay, let me tell you somewhat. Suppose we're having a wave equation. This is equation of wave. Actual equation of wave is this. K is the wave number, omega is the angular frequency. This is a path difference. This del phi is equals to how much? You see the del phi, it is equals to 2n plus 1 pi here. Okay. So through this, you'll get the path difference. This is the path difference here, students. 2 and 1 plus lambda by 2. Okay. This is the path difference in front of you. Please note it down. Please note in these values. Okay, I'll explain you something now. Please hold on. See, for destructive, what do you mean by destruction? When I say destructive, it means destruction. It means what? Dark bands. Okay, intensity goes 0 there. Okay, it means intensity goes 0. So if you add both of these waves here, you'll get the net result to be like this. This is the net result here. Okay. See, again, we'll see the interference. Suppose we're having a source S1 light. This is S2. And these two waves are interfering like this. Okay. Finally, we'll see on the screen, there's a bright and a dark bands, bright and dark bands. See carefully. This is bright band, this is dark band, this is bright and dark. This we have seen in the animation. And the mathematical equations for this are, you have to see the mathematical equation also. What are the mathematical equations? Okay, I'm writing here the mathematical equations. See, if you talk about the bright band, for the bright band, delta x equals to n lambda. Okay, phase difference is equals to how much? It will be general angle is what? 2n pi. Okay, and for the dark band, if you see, it will be equals to 2n plus 1 lambda by 2. Okay. I mean the part difference. Sorry, 2n 1 plus lambda by 2. Yeah, that's fine. Okay. And if you see the general angle there, general angle phase difference will be how much for the dark band? It is equals to 2n plus 1 pi. Remember this thing. Now, students, directly will switch to the Young's double slit experiment. See this on your screens properly. What is Young's double slit? Suppose there is a source of light. And suppose the rays are coming from this. Okay. See, Young's doubles, as there is an interference, there is what? Bright spot in the dark band, bright in the dark band. Similarly, it also happens in this YDSC experiment. Okay. Suppose you're having a source of light here, students, and the light rays are going like this. From first cardboard, it's one slit. From the second, there are two slits. So when they will pass of these two slits, finally they will overlap here. Okay, and you will get a pattern here. This is what a pattern here. Okay. See, students, carefully. Why is the requirement of this two slits here? What's the requirement of this two slits? If you see this first source, maybe the light rays which are coming from it are incoherent. Maybe the light rays which are coming from it are what? Incoherent or polychromatic. Okay. And the light rays, when it will pass from both of the slits, when it overlap on the screen like this will give you what? Dark and bright bands. This will give you what? Dark and bright bands. Okay. Okay, students. So now we'll see a little bit more explanation of this. Hai? We'll see some mathematical equations which are connected to this YDSC. Suppose this is a source of light. Okay. This is S1 source, this is S2 source. And the light rays are passing from this and they interfere on the screen on the other side. Okay. So understand this. See this thing. The part difference between these two, if you focus here, see, focus carefully, okay? And got skipped somewhat. So I'm drawing this. Yes. Suppose this in front of you is the source of light. See, this YDC is very important, okay? Suppose this is a source of light here. And we are having two sources and we are having the slits here. This is one slit, this is a second slit, okay? This is S1, this is S2. So what will happen? Light rays will pass from this S1 and S2 and it will get overlap here on the screen like this. So when it will overlap on the screen like this, so students, now we'll see that there will be pattern build here. Okay, there will be what? A pattern build here. Suppose we know the pattern, how it will look. It is the maximum at the center. It's a central maxima. There will be the dark band here. Then there will be maximum condition. Then there will be dark band. Then there will be maximum condition. Then there will be dark band. Then there will be maximum condition. Then there will be dark band. Then there will be maximum condition. Okay. Then there will be dark band. There will be maximum condition. There will be dark band. There will be maximum condition. There will be dark band. There will be maximum conditions. Okay. So see the waves which are reaching from S1, S2 at a point P with some phase difference. As we can see the power difference here. Okay. Okay, students. So from this we'll get the y value equals to this much. That is del y equals to d by capital D here. This is the y value. We'll get the power difference to be y d by d. So from this we can see y equals to power difference into capital D upon d. This will give you the y distance where you will get the different conditions of what are the maximas or minimas there. Okay. Is it fine? Please reply in the chat box. See, in this YDSC, only two conditions are important if you focus. Position of bright fringes and position of dark fringes. If you focus for the bright fringes, power difference here equals to y d by d. See, if you're thinking like this case, a derivation, see, you can see on the PDF. It's not so important. You can see this directly the formula. We know the power difference is this, na? We'll put in the formula. Okay, this is actually the formula made. You have to remember this formula first of all and this formula again. Okay, so this is the formula of on the screen we see. This is the formula starting from y equals to 0, which is the condition for the central maximum of the bright spot. As we progress from n0 to n1 and n2, so what's going to happen with the increasing y, we'll get what? Starting from this, y is increasing, we'll get different values, state 0, d lambda by d, 2 d lambda by d, 3, capital D lambda by d. These all values will give us the position of maximas and minimas there. Okay. And if you see this equation, this is y equals to 2n plus 1 capital D lambda by 2d. If you see here, this will give you the y position from the central maximum, that for where there will be the dark fringes. Okay. So this is something known as, students, simple, that is fringe width. This is something known as fringe width. Okay. Remember, this quantity is basically a distance between the same two consecutive bright bands or consecutive dark bands. Okay. If we talk about the bright band, it will be bright fringe width. If we talk about the dark band, it will be dark fringe width. It's like this: yn plus 1 minus yn. Suppose we're using the formula of the bright fringe. So it will be n lambda by d. It's n plus 1 minus n lambda d by d. Okay. This will give you the answer as d lambda by d. This will give you power difference or beta fringe width. If you talk about fringe, capital D lambda by D will give you the dark fringe. Why? We know the formula for the dark fringe, it's equals to 2n plus 1 lambda by 2 capital D by D. Okay. And this is n plus 1. That is, if you see for the n plus 1, this will be 2 of n plus 1 and plus 1 lambda by 2 capital D by D. If we subtract these two, okay, we get the answer is equals to this. That is capital D lambda by small d. Okay, fine. So we can conclude from this that for both the bright fringes and the dark fringes, the formula of the fringe width is same. That is lambda capital D by D. But bright fringes are having the same intensity, matlab they are bright. And the dark fringes are having the zero intensity, they are dark. Simple. Okay. So in the next class, students will see some, this was a graph. You have to remember. This graph is what? I mean, if you go like this, it's the intensity versus starting from the central maxima. If you go up y or down y, the central one is the maximum there. And okay, it's like this. If you go from the central position, this will be central maximum. Then up you go, this will give you different maxima conditions, and down you go, this will go give you different minima conditions. Okay. See, this is a question in front of which asks from you, कि for YDS experiment are illuminated by two different lamps emitting light of same wavelength. Will you observe the interference pattern? Yes or no? So the answer is no, students. What's the reason? Because if they are two, they will not be coherent. They must be coherent to show this what interference pattern. Okay. Next is this. In this experiment, interference of light is given by this slits equals to 0.2 centimeter apart there. Okay. And they're having the wavelength equals to 5896 Armstrong. Okay. Fringe width पूछ रहे हैं कितना होगा? What will be the fringe width if the screen is placed at d equals to 1 meter? We know the fringe width formula either for the bright or the dark will be same. That is beta equals to lambda capital D by D. Fine. Okay. So put these values here. You'll get the beta value equals to this. That is 0.3 millimeter. Okay. Simple. Let us see one more numerical now. Yeah. This is a very good example, from YDSC. If the intensity of the maximum intensity of YDSC is given as I naught, they're asking you intensity at a point on the screen where the phase difference is given as pi by 3 and part difference is given as lambda by 4. Okay. So intensity is equals to I max cos square phi by 2. Phi is basically the phase difference. And we know this thing, K delta X equals to 2 pi by lambda delta X equals to del phi. Del phi is equals to how much, students? Del phi equals to pi by 3. Del X, students, if you'll see here, this will give you delta X to be what? Lambda by 6 here. Okay, fine. Now we need actually phi angle. Phi we are having actually pi by 3. First answer we can get easily. Put the value, we'll get the intensity maximum to be 3 by 4 I. But for next, we'll use this approach. Next, part difference is given, na? Part difference is given as lambda by 4. K delta X equals to del phi. Delta X equals to lambda by 4. K is equals to 2 pi by lambda. Del phi angle we'll get as pi by 2. In the intensity formula, we'll see I naught by 2 is the answer. Okay. Okay, students, is it clear? I hope it's fine. So, students, this is all about today's class. Now I'll be ending the class. Okay. Time is up. We're having 5 minutes remaining.